2. Balancing of redox equation. Example 2. It's on the board. As you can see there, the first step, just as you know and I know, is to find the oxidation number of manganese here and check what it is here. Find the oxidation number of iron here and check what it is there. Anyone that has its oxidation number decreasing invariably is the oxidizing agent. Anyone that has its oxidation number increasing is the reducing agent. How do we know? Like I have told you, let us do it by the side. We want to find out the oxidation number of manganese in this compound or in this ion. We are equating it to -1. Don't forget this charge here. You're equating it to -1. So manganese plus that of oxygen is -2, but we have 2 oxygen there equals -1. Manganese -4 equals -1. -2 times 2 is -4. Okay? Equals -1. And you know why we are equating it to -1? Because of the charge on top of the compound. So manganese equals -1 plus 4 invariably. If -4 is crossing this side, it becomes +4. So this is equals +3. -1 plus 4 is +3. That is to say that manganese here is +3. And it's now +2 here. Iron, okay, is certain. The ion's own is very certain. This is +2 and the +3. It then means that manganese changes from +3 to +2, while that of iron changes from +2 to +3. If you watch, manganese is decreasing. Manganese is decreasing, while iron is increasing. That is to say that the whole of this is an oxidizing agent, because manganese has its oxidation number decreasing in the positive direction, while that of iron is increasing from +2 to +3. It's an increase. So it is the reducing agent. The next step is to put the oxidizing agent on the reduction half equation and put reducing agent on the oxidation half equation. Oxidation half equation, I have represented the reducing agent in the oxidation half equation because it is the one that is oxidized. It is the one that is oxidized. First rule, balanced number of atoms. One ion, number of atoms is balanced. Second rule, balanced number of charge. Charge of this side is +2, while charge of this side is +3. How do you balance it? You add electron. You add electron here. 1 electron. Because this side is +2, this side is +3. What do you do now? So if you check very well, here it has become +2, and here has become +3 minus 1. 1 electron, which will give us what? +2. So number of charge is now balanced. Let us go to reduction half equation. This is reduction half equation. Manganese and the manganese. 1 manganese, 1 manganese. To balance number of oxygen, what do? Add water. I'm adding water here. And I have told you, if you have added water, invariably hydrogen has been added. What do you do this side? Add hydrogen ion. Add hydrogen ion. Now start balancing. 1 manganese, 1 manganese. 2 oxygen, 1 oxygen. So what do? We add 2 here. So that these 2 will affect oxygen. That is now 2 oxygen. How many hydrogen? 2 times 2 is 4 hydrogen. The number of atoms is balanced. 1 manganese, 1 manganese. 2 oxygen, 2 oxygen. 4 hydrogen, 2 times 2. 4 hydrogen. The next step is the balance number of what? Charge. What is the total charge we have here? This is minus 1 for this one. And this one is plus 4. Which is what? Plus 3. What is the total number of charge we have here? It's just plus what? 2. Water is neutral. You don't touch it. It has no charge. So this side is plus 3, this side is plus 2. How do we balance it? How do we balance it? We are going to add electron on the left-hand side of the equation plus 4 hydrogen. How many electrons are we going to add? 1 electron. Plus manganese, and now 2 molecules of water. I have added 1 electron. So that one will subtract from 3 to give me 2. So check it again. All these ones is plus 3 and the minus the 1 I have added, which will give me what? Plus 2. Plus 3 minus 1 is plus 2, which will balance this side, which is what? Plus 2. Remember, I added 1 electron here, so that if we minus it from 3, it will give us plus 2. Now, the next thing for you to do is to consider number of electrons on both half equations. Remember, this one will form equation 1, while this one will form equation 2. So check number of electrons on equation 1, it is how many? 1 electron. Check number of electrons in equation 2, it is the same 1 electron. So in this case, we are not going to multiply any of the equations because the number of electrons is already balanced. 1 electron in equation 2 and 1 electron in equation 1. So what do? We cancel them straight away and now combine the two half equations to get our overall redox equation. Let us now combine the two half equations to get our overall redox equation. Combine equation 2 and equation 1 to get the overall redox equation. Look at it. Remember, this is equation 1, this is equation 2. I am picking now. I pick this one, which is here. I pick this one, which is here. I'm done with the reactant of equation 2. I'm now going over to the reactant of equation 1, which is this, and is here. The reactant of equation 1 is complete. I'm now going to the product of equation 1, your equation 2, which is this. This one is here. 2 molecules of water is here. And now ion 3 ion is here. That is the overall redox equation. Having considered all these redox reactions and their examples, and I hope to meet you at the comment section. In case you are still having difficulty in any of these balancing or redox equation, comment. Say your problem there. We will address it. Thank you for watching.